Okay, guys, hi everyone. Sorry that I could not make the office hours today, but I think these videos might be even, more efficient in terms of time consuming. So I have two topics to discuss and I will do separate videos. The first topic, I know now you are going through the inventory management. And I think this is quite important topic because it is applicable in real life. And when I did my internship in GEP, I actually used these concepts that you passing through right now, like what is inventory, what is base stock, what is safety stock, what is cycle stock. So, and today I want to walk you through this. So first of all, let's repeat once again what you just did in your previous classes. So we discussed news vendor problem, and we assume that our demand follows the normal distribution. So you have like the average demand, and you have some variability of your demand, which is described by your standard deviation, right? So, and what we said that our service level is basically the probability that we will satisfy the demand, right? So the demand is less or equal than Q, and we want to find this Q, right? So also we discussed that the service level, if it's not given, and it is usually given actually. So when I did it in GEP and we did it for our client, we just said, okay, we want our service level to be 90% or 95% or 99%. And basically we provided the client all three scenarios and what client is really interested in. So when we find our Q for like each SKU, let's say QI, so then you multiply it by cost of this SKU and you summarize it. So this cost is what really your client is interested in. So they know how much money will be frozen in inventory, right? So that's why we provided like them three different scenarios for three different service levels. So, but in this class, we said, okay, to maximize our expected profit. And what is expected profit? Expected profit is the profit that we expect on average. So if we had like different 1,000, 10,000, I don't know, 100,000 iterations, and we could calculate our profit in that many times, the average profit will be maximized by choosing the Q when our service level is equal to our critical fractile, right? So basically what we are trying, this service level critical fractile, what we are trying to do, so we have probability on y-axis and we have like the demand on x-axis. So, and we have to find the probability of the bell curve first. So we go like backwards. We find the probability and then we find the Q. But actual formula for the bell curve, you might know this. It's actually the ugly formula. Let me delete this first. So it would be something like y is equal. I don't know I don't remember the exact like coefficients, but it depends on your mean and standard deviation. I could mess up with this formula, but you can find it online. What I'm trying to say, so this relationship between like between probability and demand, this relationship for the bell curve, it's non-linear, right? And we go backwards. So we first find the probability on this side, right? And then we find our Q. So just reminding you, the critical fractile is P minus C divided by C, or it's underage cost divided by underage cost plus overage cost. And I like this formula more because when you say underage cost, like cost of having not enough underage, so cost of having not enough. So basically you can choose, you can add to this number whatever is important for you. For example, cost of losing customer, or cost of your reputation if you don't have enough products, right? So in this upper formula, you think only about like your retail price or your wholesale price and your cost, like how much you paid and how much you sold it for. But here you can think about like different factors, and that's why I like this formula more. So, and this like idea behind the critical fractile and service level, it will remain the same for multi-period. So we did it for the news vendor problem when we just have to buy this inventory once. Like, why news vendor? Because tomorrow you're not gonna read the newspaper from today. So that's why this particular newspaper that you are selling today, you have to make a decision just once. So I just want you to like remember this. So, and how did we start like the optimal queue, the optimal inventory? So we used norm in function. If we're talking about Excel. So when we had like 3 parameters, like we had service level, our mean, and our sigma, our standard deviation. So basically what we did, this bell curve, it's like it's always the same, but the spread can be different, right? So it can be like this, or it can be like this. But no matter how it looks like, you pick a point, which is your service level. And let's imagine you have 84.1%. So this means you want to satisfy your demand fully in 84.1% of time. Why did I choose this number? Because if we go, so this point, like where we have average on x-axis, where we have our mean, our mu. So this corresponds to 50% probability, right? So, and if we go 1 standard deviation to here, to right side, if you remember this, so it's 50 plus 30, 50 plus 34.1. So actually, it's not in here, right? Yeah, it's in here. So, and what you do by this function, it's basically, if you like read the scientific article, it would be shown like f minus in power minus 1, but it's not a power. This just means inversed function, right? Inverse, because we, again, as I said, we go backwards. We first find the probability to satisfy the demand, which is our service level, and then we find the Q corresponding to it. And how we find it, we have norm in function, which is the function of our service level, our mean, and our standard deviation. This is how we find the Q, right? So now, when we go to multi-period problem, let me delete all this. The concept remains the same. The concept remains the same. So I just have to say that we do have two types of inventory. We have two types of inventory control, inventory management. One is called periodic review, right? This means that you make your decisions once a day, or once a week, or once a month. Why? Because before you make a decision, you want to see your sales data, which makes sense, right? So I want to collect the data from yesterday to make my decision today to order some quantity, which, for example, will come to my warehouse tomorrow, which is usually not the case, right? So if we draw the timeline, so we have like discrete timeline when we make decisions, right? And every time when we make a decision, we look backwards in our demand. And ideally, we want our inventory look like this, right? So what does it mean? So we here our inventory goes down. We are selling. Now in this time period, we order something. So, and we got back to this point in our inventory, and we like again it's declining because we have demand, and then we order again and again. So this upper point, this is B or beta. I honestly don't know how she call it in during the class, but this is your base stock. So this is your base stock, or another name for this type of inventory management, like periodic review. It is called up to level. So which means every time you make an order, like in your T1, T2, T3, you make your order up to this level. No matter how much inventory you have on hands, no matter how much inventory you have on order, you summarize it, you sum up it together, and then your order would be your base stock minus your inventory on hands minus your inventory on order. We will get there. I just want you like to show what different policies are usually used. And in this class, we will mainly talk about the this periodic review. So another story when we have continuous review. And continuous review means that you can like check your inventory, not you, maybe machine, your computer. You can check your inventory at any time. So it goes down, goes down, goes down. And there is some reorder point. And when it hits reorder point, so yeah, this is inventory, sorry, it's inventory, this is time, right? So when it hits your reorder point, you order again. And you order some Q, which is usually like the same number every time. And this Q, it's a function of your standard deviation. Okay, let me delete this. function of your sigma, right? Why so? Okay, let's go back to Nussbaum problem. You remember in the last homework, she had this like problem, and she called it pull to center effect. Pull to center effect. So what does it mean? It means that if you don't know anything about this critical fractals, standard deviations, variability, and normal distribution, how much would you order? You probably would order the average. You would order the mean, right? This is something very intuitive, right? No matter how much you earn on this. And then by intuition, you say, okay, if I earn more, if I like earn more money on this product, I probably will order a little bit more, which means you go to this side on your bell curve. And basically this means that you take this risk, like this standard deviation, this variability into account, right? And you order more. Or if you don't earn money on some particular product, you would order less than average, right? And basically this means that you go to the left side of your bell curve, and you again take into account this sigma, and you buy less than you expect to be your average. This is the intuition behind it, right? So this Q for continuous review, it depends on sigma, because when you like when you have your reorder point and when you order your Q, basically what you are doing, okay, you don't know your demand, so you buy extra to satisfy this possible area of demand, right? So now let me delete this. And now I know, I think we discussed it with Vanessa. You had like some slides. Let me check it in Canvas. Okay, I will not pull slides in here right now. I will just keep going, and basically what I will talk here, what I will talk about here, will be the same. So we had this Nussbaum problem, right? And now we are saying, okay, we have multi-period. What does this word multi-period mean? It basically means that we have lead time, so which means lead time is basically your delivery time, right? I mean, not yours, but it's delivery time of your supplier. So if you order today, in how many time periods? It can be like day, right? Or it can be week. Usually it's week, but it can be also months. So when it will come to your warehouse. And we have a review time. Usually review time is just equal 1. So what does it mean? What does it mean review time is equal 1? It means that when I make my decision today, I make it based on my historical data, and the latest historical data I have is yesterday, right? So like in my inventory management, sorry, I have to close the window. It's my kids playing outside. So yeah, we have our yesterday demand, the latest, right? So, and we are kind reactive. We are react on our demand. So that's why between yesterday and today, when we make a decision, at least one day, right? and I cannot make my decision today based on today's demand because I don't know my demand yet, right? So now what happens if we have this multi-period? Basically, guys, you will be surprised, but we solve the same problem as we did for news vendor. It's almost the same, but what changes? So the whole idea of this is that because you are not going to discontinue your product as we did in news vendor problem, right? You want your inventory should last. Okay, let me stop writing. Okay, your inventory should last until your new order comes. And that is why you have to learn the very basic concept. The driver, so the inventory for any product, inventory is the function of course, service level, but I was gonna say the lead time. So what drives your inventory? What makes you to have a lot of inventory? Your lead time. So if you have some product that you order in China, and you know that, and I worked in a company that had this lead time to be 6 months. This means that within these 6 months, you will have to like sell something, right? And within this 6 months, your inventory will have different components, right? It will have different components. Your inventory will have inventory on hand, right? It's basically your warehouse. And it will have your inventory on order, on its way, right? And basically what's on order and what's on its way, it also has like different components. It may have different orders, right? Because you remember, if here we have like this time T1, T2. So every time, like when it's T1, T2, you make an order, right? You make an order, you make an order, you make an order. So, and all these orders before it come to your warehouse, it's part of this inventory on order. And also part of your inventory will be queue, how much you order today. And this summation, this is your base stock, as I said. And what we are trying to do here, we basically solving exactly the same problem as we did for news vendor when we discontinue our product. But now we're trying to find the base stock up to level. You remember that up to level, which will be actually the norm in function based on new service level, new mean x. X is how many periods in like how long is lead time, right? And your sigma x. So for the news vendor, we had Q inverse function of service level, new, and sigma. And now we have very similar formula, right? So this is for Q for news vendor, This is for base stock. So instead of Q, now we have base stock. This is what we are trying to find. And we have not enough parameters in here, right? Service level is still critical fractile. And it's still based on your P and C, basic mainly, yeah, and maybe salvage value. So this one stays the same. But this average and this sigma for multi-period, they will be different. And how they will change, I will show you right now. Okay, think intuitively within the time. If we have lead time, right? And now you have to predict your lead, you have to predict your demand. You have to predict your demand. You have to predict your demand based on your lead time, right? And if lead time is longer than one, then what would happen with your average? Your average demand during that time, during the lead time. Actually, not only the lead time, but it's lead time plus review time, which is usually 1. Or it may be given, but in real life, I would say it is 1, right? So your new average, I think she said it, x, right? So your new mean x is basically your regular mean, your regular average, multiplied it by lead time plus r. Does it make sense? So if you have multi-period, how much will you sell on average during lead time plus review time? How much will you sell? You will sell your average sales during one period multiplied by this time, right? So because every day, every time period, on average, you will sell your mean. So then the new mean will be your mean for one period multiplied by time within you wanted to sell, to be sold. So we found a component for our new bell curve. And if we go in here, and I remember here we had probability, so here we have like our demand, right? So it's the distribution of the demand. Oh, okay, now before I draw the new bell curve, what will happen with our sigma? So our sigma x, actually, you know, in Professor Akimovich videos, he showed us like different ways to calculate the sigma, because we take here the very simple problem when our lead time is constant. But in real life, it's not constant, right? So the lead time can vary, and we can take into account this variability. But if we now forget about it, the simple case will be, okay, we take our sigma, but you remember, because like standard deviation is square root of like the average of the distances between your mean and each demand data point, because it's like the root square. Then the relationship between between sigma and our sigma for one period will be like this. So it's sigma one period multiplied by lead time plus your review time. So now we have all three components for like predicting the new demand within the lead time and review time. So it will have a new average. The spread will be higher, like the longer, because the variability during the time within the, like the more time you have for your lead time, the more your variability, right? So it will look like this. You will have your new sigma x. And this, so instead of, it still will be your, so we still find some service level, which can be a critical fractile. And it can be the same as here. So nothing changed, right? Basically, you're trying to find corresponding Q, but this Q is a base stock. This Q is your up to level. And this actually makes sense, right? So what we are doing here, okay, we have lead time. Lead time drives our inventory upper. And to be safe that we have enough inventory during the lead time, we will set up our inventory as our average demand during that time, during lead time plus review time, right? And we take a little bit more because demand is variable and you want to have inventory to satisfy that demand. You go to this side of your bell curve, you find a new Q, which is your base stock. And this base stock will be a foundation for your inventory management. So now I think we are ready to, like, I'm ready to show you the formula which actually helps you to find your base stock. And this is what you can do in real life. I actually promised to show you like on some data, and I will, maybe not today, but I think this is very important, like to cover. Okay, now your base stock is kind of, it's kind of your Q here. It's norm in function in Excel, right? Your inverse function with the service level, with your mean, which is actually your mean for one period multiplied by your lead time plus your review time. And your new, okay, let me erase. Hold on. And your new sigma, which is actually your sigma of one period multiplied by a square root of L plus R. So you see, we are solving exactly the same problem as we did in a news vendor. But what is different now that we have this new mean, which is actually mean of the whole period while you wait for your product, and new standard deviation, right? And now, how do you make orders, right? Because this is something you want to do as a purchase manager. So as I said, your inventory, your base stock, your up to level, yeah, base stock or up to level. Oh my God, why it takes so much space? Okay, it's your up to level. It has different components. It has inventory on hand. It has your inventory on order. And it has your queue. We can call it different. We can call it queue star. But this queue, the order. This is your order. So your inventory on hand. Look, imagine you are the purchase manager. You work for Best Buy. You work for Amazon. You work for Target, Walmart, whatever. So inventory on hands, known, right? It's given. Inventory on order. Normally you can see it. It's known. Base stock. It's calculated, right? Oh my God. So base stock is calculated. So this is given, this is calculated, this is given, this is given. Now you can find your queue, right? Okay, let's make it bigger. Next to my brother-in-law, I have this computer with touch screen. Now you can find your queue star, your order. I apologize if, like, in her slides, she called this differently, but I'm pretty sure you will, like, figure this out. What is what? So your queue order is your base stock, which is, again, the function of your service level, your mean demand during the X time, your standard deviation during the X time, minus your inventory on hand, minus your inventory on order, right? So this means if, like, any order doesn't cost you anything except your how much you pay per each queue, ideally you will order something each time period, right? So every week or every month you will order this much. Your up to level minus your inventory on hand minus your inventory on order or on its way. Cool. So the last thing that I have to show you. So again, ideally, this is your inventory. This is your time. So ideally, inventory, we want it to look like this, right? Okay. So this is our base stock. And our safety stock, no, it's actually not here. Our safe stock is here. So at any moment in time, you don't want your inventory, because this is inventory on this inventory on hand plus your inventory on order. And your your safety stock would be over here, and your safety stock is your base stock up to level minus your mean demand during the lead time plus review time. So basically what we did on the bell curve, we go back to bell curve. So we have our mean, and then we go to this side to take into account variability. This is our base stock. And then you subtract, so we took this like extra to satisfy the whole demand, right? And your safety stock is this minus your average. So basically you shift this here, and this area, this is your safety stock. And safety stock, this is the minimum that you want to have on your inventory at any moment in time. So you don't have, it's not the reorder point, because like to have enough inventory, you have to reorder earlier. So your reorder point would be over here, right? Would be somewhere between your like your, when you hit your base stock and your next review, right? So this difference is nu x. So it's your average demand. And this is your safety stock. Your cycle stock is how much would you order between the orders. This is your cycle stock, right? Okay, let me pause here. I want to pull her slides, to be honest. Let me pause it here. Oh, okay. Can I pause? Can I pause recording? Oh my God, where is Zoom? Okay. Here we go. Okay, yeah, I keep recording. I just wanted to make sure that we're on the right track. Yeah, for the safety stock, I think what we did was correct. Yeah, that little bit extra inventory. Yes, basically, and the explanation that I did on that bell curve was correct. So the cycle stock is it takes into account that we don't order every minute or every second that we have our periodical review. And basically what this formula means, we go back. Okay, this is between the orders. This is our mean between the orders. And this is our review time, right? So basically review times is equal how often do we make orders, right? So that formula is basically the area of this triangle over here. What is the area of triangle? It's your, in this case, mu, this side, multiplied by this side, which is review time, divided by 2, right? This is just the area. So again, this is the safety stock, right? And the pipeline stock, basically, this is I think it's very easy to understand. Now let's have a look into the formula. What was that? Oh yeah, here. So pipeline stock is average per one period multiplied by lead time. So it says that on average, let me delete this. On average, your inventory on hand plus your inventory on order, this will be on average equal your mu per period multiplied it by lead time. Basically, it's equal your mean demand during the lead time. Right. So if we have no variability, your pipeline stock will be equal to the average demand during the lead time. Yeah, I think this is clear, but please send me like questions here if you have it. So here I stop sharing, I stop recording. I will share with you this file. And again, I think this is very important to understand. I don't promise you to bring some data and show you how it may work today, but I promise to do it next week. What I will do today is, some of you asked me for the explanation of loss function, expected sales, expected profit. So I will record another video for that one. Okay, bye everyone.